All right, welcome back, parakeets. I hope you had a nice day off of school and took some time to honor a veteran that served our country. Today, you should have done Wednesday and Thursday's part of the morning work, so that was the entire backside of your paper. All right, let's go over this together. We are going to write the equivalent, sounds like equal, right? I hear that, equal fraction, all right? So these colored in parts here are equal sizes. Let's look at the top one. 1, 2, 3 spaces, and 1, 2 were colored in. Down here, the colored in part is the same, however, there are more spaces. 1, 2, 3, 4, 5, 6 spaces altogether. And 1, 2, 3, 4 were colored in. Alrighty. Next, we're going to find the perimeter that's around the outside, and we hear that t-t-t-t. So that means we're going to add up all the sides. If that side is 6, so is this one. And if this side is 5, so is that one. They're the same. So we add 6 plus 5 plus 6 plus 5. And that would equal 22 meters. Oops, 22. 22 meters. All right. Rim around the outside of something. Ta-ta-ta-ta. That sounds like a T. T looks like a plus sign. Alrighty. Shade in the quadrilaterals. Qua takes 4 quarters to make $1. Quad, if you're talking about an ATV, has 4 wheels. Quadrilaterals have 4 sides. 1, 2, 3, 4. Mine are gonna be purple. All right. 1, 2, 3, 4, 5. Not coloring that one. 1, 2, 3, 4. Yep. 1, 2, 3, 4. Color, 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 color. 1, 2, 3, 4. We have quadrilaterals. Uno, dos, tres, cuatro. Great. Alrighty. So now we're over here on Sam. Sam runs 6 miles each day for 3 days. How many miles does she run in all? Draw a model to show your work. First, let's find our math problem. 6 miles one day, 6 miles again, 6 miles 3 days in a row. That is 6 miles 3 times. Alrighty, let's count by 6s. We're going to use a tape diagram to model. 6, 12, 18. There we go. We did it 3 times. 6 times 3 equaled 18. What? Miles. Alrighty, and then down here we have the area. So area is if it was covering something. We've been breaking apart our rectangles by going across most of the time. So I'm going to assume that a lot of you maybe drew a line right here. And what we're going to need to figure out is how long this part is down here and how tall this part is. Alrighty, so let's start with how tall it is. Right here, it was 6 inches altogether. We're going to break up that 6. If I bring this over, I've used 4. I had 6 altogether, and I took away 4. I hit the 4, count up, 5, 6. That leaves me 2 inches here. All right, next, I have to figure out how long this little part right here is. All right, so they said up until this corner is 7 inches. The whole thing is 9 inches. I have 9 on the whole length, 7 to here. Let's hit the 7. 7, 8, 9. This is 2 inches wide. I have, in fact, a 2-inch square down there. Alrighty, we're not done. We need to find our math problem. How tall it is times how long it is. 4 times 9 up top. Hands flat on your desk. Pinky number 1, 1, 2, 3, 4. You should have your left hand pointer folded away. That's now our switch. Let's count by tens. I have 10, 20, 30. Switch to ones. 1, 2, 3, 4, 5, 6, 36. And down here is 2 times 2, 2, 4. That equals 4. We're not done. We need to put these together. I have 36 plus 4. 6 and 4 is 10. The 0 goes down and the 1 comes up to make for 40 square inches. All right, remember we put that square in there when we solve an area problem. Moving on to Thursday's part of the work. We're talking about our favorite pets and the numbers of votes they received. All right, looks like it goes up by 2, so anything halfway is just one more. Let's look for fish. It goes past the 8 line, one more. 9 people voted for fish. Reptiles fell flat on 10. The dog won the race with 11 votes. And here between the 4 and the 6, the cat got 5. Poor kitties. All right. Now we have a few questions from reading this graph that we need to get answered. How many people like fish or reptiles? So they like this one or this one. And it's how many people all together. So we're going to take the fish and the reptiles and we're going to add those two numbers together because that means this many people like this one or that one. I see 9 and I see 10 to find out that 19 people like fish or reptiles. How many fewer? That's a cue right there that we're going to subtract. People like cats than dogs. Let's take our 11 people that like the dogs. Take out the 5 people who like cats. Hit the 5, count up to 11. 5, 6, 7, 8, 9, 10, 11. That gives me 6 people. 6 more people like dogs than cats. All right. How many more? Again, we're going to have to subtract to find the space in between, the difference, okay? People like dogs than reptiles. So more people like dogs. That number goes first. Big number first for division and subtraction. And then we're going to compare that to the people who like reptiles. There's 10. 11 minus 10 is 1. One more person likes dogs than reptiles. Alrighty, on the other side, we're going to have one of our two-step problems here. While at the fair, Finn rode the Ferris wheel 5 times and the roller coaster 4 times. If each ride cost 3 tickets, how many tickets did he use? All right, so let's find out how many rides did he go on. He rode Ferris wheel 5 times. He rode roller coaster 9 times. We put the 5 and the 4 together to find out he took 9 rides. Hands flat on your desk. He spent 3 tickets every time he went on a ride. 3 on this one, 3 on this one, 3 on that one. We added it up in even groups. We fold away number 3. We count by tens to our switch. 10, 20. Switch to ones. 1, 2, 3, 4, 5, 6, 7. 27 tickets. T stood for tickets. Finn used 27 tickets is the answer to my question. All right, wonderful. So we are going to compare fractions. When we're comparing, we're talking about greater than, less than, or equal. So we can see that this top one is a little bit shorter than the bottom one. 1, 2, 3, 4. 4 parts. 1 is colored in. 1 is colored in here. And there are 1, 2, 3 parts in all. 1/4 is less than 1/3. All right, great job on your morning work. Either hit pause or let's switch over to last night's homework. I'm going to go over one on each page. The rest should be a review, or you can go over with a partner if you need to. I'm going to choose, let's go with C. The problem was 8 times 7, okay? 8, 16, 24, 32, 40, 48, 56. All right, if I kept up with my fingers, that was 7 times. So things should check out here at the end at 56. Let's see. Each block is worth 7. 1, 2, 3, 4, 5. So they took the 8 blocks. They put 5 and 3. 5 times 7 is 35. 1, 2, 3 blocks, or 7 each, is equal to 21. So we said the 8 is 5 plus 3. And if we break this out, we said that was 5 times 7 plus 3 times 21. Or 3 times 7, 21. Getting ahead of myself. Alrighty, so we took that 35 and 21. The 1 and the 5 make a 6. The 2 and the 3 make a 5. Shirley was 56. Check. Check. All right. I'll turn the page. We're going to go shoot some arrows at these targets here. I like the second one. It says 63. That's going to be boss. Divided by, well, that looks like that. A number, we're going to call that n. There's what equals looks like, 9. 63 divided by n equals 9. Choo. Hit the target. Alrighty, so the rest of yours should match up. There, check with a partner or go over it in class if you need to. And let's go down to the bottom and figure out what Mr. Lucas. Mr. Lucas divides 28 students into 7 groups for a project. Draw a tape diagram and label the number of students in each group as n. Write an equation to solve for n. All right. So, matrix is up here. Our groups are going to be 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And n is going inside. We know the whole thing is 28 kiddos. All right, so there I am with 7 groups. I have 28 kids. How many end up in each group? 28. Shared into 7 groups equals n. 7, 14, 21, 28. Oh, that was 4 times. N equals 4. So if we filled these in, I would have 4, 8, 12, 16, 20, 24, 28. All right. So that was that. A little bit backwards from the way we usually do them. The point being that you're able to get the correct answer. So if you have an n and you were able to make it equal 4, well done. Alrighty, moving along. Probably a great time to hit pause. You'll get out your work for today. We're going to be going over the lesson 8 application problem when you get back. So go ahead and pause the video at this point. Go to work, and I'll see you soon. You did give you the opportunity to work in partners today. Put your mask on perfectly. Put your nose away. Get there quick and quiet. You know how we do it. All right. I'll see you soon. Pause. Alrighty. So hopefully you found that pretty easy to do. And we are back and ready for action. I'm not sure I can get the whole thing in the screen for you, but I'll keep the work in the screen. I'll read out loud. Our application problem says, Richard has 2 cartons with 6 eggs in each. He opens the cartons. He drops 2 eggs. How many unbroken eggs does Richard have left? All right, well, let's see how many eggs he started with at first. He had 2 cartons. That's the group, the holder. And how many were in each? 6. He had 2 eggs. But that was not the end of the story. Or 12 eggs, I think I just said 2. As he opens the cartons, he drops 2. How many does he have? He had 12. 11 and 10 hit the, or 12 and 11 hit the floor. There went 2. Leaves him with 10 eggs. How many unbroken eggs does Richard have left? Richard has 10 unbroken eggs. Alrighty. So now we're going to be doing some work. I want you to take this opportunity and write PEDMAS up here if you have not already. We saw parentheses, exponents, division, multiplication, addition, and subtraction, and we saw them from left to right. Alrighty, so following those rules, we'll start at the left. My first question is, are there parentheses? Yes. 12 minus 4 is 8. And we still have a plus 6. 8 plus 6 is 14. Part B says they move the parentheses, and let's see how it changes the problem. So we're going to say parentheses first. 4 plus 6 is 10. 12 minus 10 equals 2. There's those same 3 numbers in the same order, and look what different answers we have. Alrighty. So, are there parentheses here? Yes. 7 plus 3 is 10. That gives us 15 minus 10, which would leave us 5 equals 15 minus 7 plus 3. Alrighty. Down here, parentheses. So we'll do the 15 minus 7 first. That would have given you 8. And then we add the 3. 8 plus 3, 8, 9, 10, 11. Alrighty, E. I do have parentheses. I'm going to solve inside there first. 3 plus 2 is 5, and then I have a times 6. 5 times 6 is 30. Okay. Underneath, same 3 numbers, different order. We're going to solve the parentheses first. 2 times 6, 6, 12. We had a 3 plus 12 now. 3 plus 12 is 15. So they call this the order of operations, and oh, how we can see how it matters. Not one of these has given us a matching answer with matching numbers in the problem. Alrighty, do I have parentheses? Yes. My parentheses say I do. 7 minus 2 gives me 5. And now I had multiplication. It was 4 times. 4 times the 5 I have is 20. Parentheses, yes I do. 7, 14, 21, 28. Multiplication, no. Division, addition, subtraction, there it is. A minus 2, 28 minus 2, 26. Still no match. Alrighty, that should be a good run through for you to be able to do the other half of that paper. I'm going to jump down to 2. Use parentheses to make the equations true. Ooh, how tricky. Alright, so this must equal 19. The first way we're going to do it is go 16 minus 4 inside my parentheses plus 7. And we're looking for this to be equal to 19. 16 minus 4 is 12. And now I have plus 7. That does in fact equal 19. Let's check to see if it works the other way. 16 minus, now we'll put the 4 plus 7 in the parentheses. 4 plus 7 is 11. 16 minus 11. Oops. Is 5. Which is not equal. Nope. So when you draw a slash or the equal sign, that says does not equal 19. It equals 5. Okay, so we would want to put our parentheses here to make that true. Oops, I almost covered the plus sign. Alrighty, let's try D. 12 equals 22 minus 15 plus 5. So it would either be 22 minus 15 plus 5 or 22 minus 15 plus 5. All right, let's see which one of these parentheses makes our problem equal to 12. 22 minus 15, let's hit 15 and count up. 15, 16, 17, 18, 19, 20, 21, 22. That is 7 plus 5, and that equals 12. All right, 15 plus 5 inside my parentheses on the second part is 20. 22 minus 20 equals 2. So we want to put our parentheses around the 22 and the 15. Ooh, all right. Let's see. I'm feeling like letter G is going to be the one for us. Some dividing in here. We haven't done that yet. All right. So we want it to be equal to 5 when we're done. Let's put our 10 divided by 10 in the parentheses first and leave our times 5 outside. Anything divided by itself equals 1. 1 10 can go in a 10. 1 times 5 equals 5. Everyone I've picked, the first one has ended up equaling it. It's odd. Odd odds. Strange odds, maybe. All right, let's take 10 divided by and leave it on the outside. And we're going to put 10 times 5 on the inside. 10 times 5 is 50. 10 divided by 50. Oh, 50 can't go in a 10. That's definitely not going to work. All right. So where those parentheses goes matters. That was probably pretty tricky. We're going to have plenty of practice. If you felt better up top here, this is where I would expect you to be pretty comfortable solving what's there, following these steps. Down here, this is really beginning to challenge you. If your brain kind of felt mushy down here, you are right on schedule. There's nothing wrong with that. Alrighty, then let's go over number 4 together. Natasha. Natasha solves the equation by finding the sum of 5 and 12. So the sum is the answer to an addition problem. Place parentheses in the equation to show her thinking, then solve. So the sum of 5 and 12. I have my 12. If I put my 15 and my 3 inside parentheses, I would solve that first. 15 divided by 3 is equal to 5. So then I would have that 5 plus 12 I was looking for. And if I continued to go on to solve that, I would find that 17. The sum of 5 and 12 is 17. Okie doke. So that was your problem set. On your exit ticket, let me take a peek. Use parentheses to make the equation true. I know this is challenging if I can see you trying. So you'll either put the parentheses on the first 2 numbers, and then you'll move them and put them on the last 2 numbers. Solve the ones that you can. I want to see your work though, right or wrong, I need to see that you worked. And then this is just like that one that we did. You should be able to do this one without too much trouble. Great place for another pause while you work on your exit ticket. All right, your exit ticket should of course have your name on it. Miss P. Smiles. All right. And we are going to get a pretty cool poster for you to continue practicing this PEDMOS. I have a colored in example. They're now at school with you, ready for you to check. I'll put it on the magnets on the board for you so that you're able to check on it if there's something you don't feel comfortable with. Coloring it and making it nice is going to be pretty important. Work from left to right. You're going to want to write those in. We're going to write down some practice, PEDMAS, and we're going to solve these here. I do want to take a quick moment to stop ignoring E. And even though we aren't going to do it in 3rd grade, it doesn't mean you can't prove that you're smart as a 4th or a 5th grader, even college kids. So, without thinking too much about it, an exponent is a teeny number up top. So let's say that we have a 2 with a teeny tiny 2 up top. All that says is this number here is going to be times itself 2 times. 2 times 2. All right. So what if we had a 2 with a 3 up top? That would say 2 times 2 times 2. All right. 2 times 2 is 4 times 2, 8. All right. Let's do it with 4s. So if there was a 4 with a little bitty 2 up top, that would say 4 times 4. That would equal 16. What if there was a 4 with a teeny tiny 4 up top? That would say 4 times 4 times 4 times 4. 4 times. 1, 2, 3, 4. All right. Uh-oh. 4 times 4 is 16. Miss Parrot. Well, what if we made the 16s 10 and 6? 16 times 16. Oh, man, no wonder they left that for 4th or 5th grade. All right, go make a cool poster. Study these things. I just wanted you to know what an exponent is. We won't need to be doing them, but at least you have a little bit of, you will be using it later. It's not that hard, but just something for you to think about. I truly miss all of you. I hope you're doing great. Tomorrow we'll be doing our math test. I look forward to seeing some A's for my grade book, and I am counting down the days. This leaves 6 left until I get to be back in class with you. All right, I hope you guys have a great rest of your day. Enjoy making those posters. We'll make them colorful and decorate that front board. All right, bye.